Hello, welcome back. In the last video, we have found out the range of A such that if you draw normal from 2A and B, this means we will get three normal. Means in order to draw 3 normal from point to A B, what would be the range of A? This is what we derived in last video, but there is a little correction there, and that correction in terms of like A, because that A to AB is with respect to normal coordinate, normal what you say normal parabola, but actually the vertex of the parabola is there at x equal to 1, right? We have found out vertex of parabola at 1 2 exactly, right? Then here value of A would be then greater than 1, because we need to take this shift in account also, because your parabola is kind of got shifted here. Vertex, if vertex 0 0, that's fine, but it's got shifted here, right? And then we will have more room here, and because of that reason, actually if you take that one into account, your answer will be greater than 2. Okay, don't get into the so much confusion, and don't get into this confusion. I will give you intuitive way to solve this kind of problem. This kind of problem means the problem where you have a normal, 3 normal, right, from a point, right? There is a very intuitive method to find out this. Okay, let's assume you have a normal parabola here, and if you have some point, and from that point if you are able to draw three normal from this point, so there would be a condition like your this point A, A will get mixed up with this. Let me take some PQ or some point. Let's take HK, because that will get mixed up actually. Okay, HK, so that your point H should be greater than 2A. That's it. Okay, that is that's the relation. H should be greater than 2A. Okay, if your H is greater than 2A, and you can draw normal, means 3 normal in a parabola. What does it mean? It mean like if you have H is equal to 2A, A is like this is point A0, your focus, and 2A will be somewhere here, means somewhere here. If you are drawing a perpendicular from this point, means the point which is falling where H is greater than 2A, means from any point you take, right, in this region, if you draw at normal from any point, you would be able to draw 3 normal. If you go, if you come back to this region, you won't be able to draw 3 normal in this region, right? Only this region will support 3 normal, real normal. This region will not support. Okay, if you keep this one in your mind, like if this is the focus distance A is the double of focus distance, right? And means this region, just you draw your parabola and check the focus point and just doubled it from vertex, just doubled it and just declare, okay, this point would be your the point where you can draw 3 normal. Okay, so if you take that one into account, then your problem will be solved here. So H is greater than 2A, right? 2A. Okay, that's it for this problem. Actually, your H is equal to 2A. This A is different than this, and actually your 2A is equal to 4. Okay, not 4, this is 4, right? 2A is equal to 4. 2A, I mean A is your equation y square is equal to 4x, means that one, that is equal to 4. It means your H means 2A should be greater than 4. It means A should be greater than 2. Okay, that's all. You don't need to get into this much of equation, nothing. It is just find out your find out S means focus, and just take double distance, and means just put draw a lattice rectum simply, right? Just not parallel to lattice rectum at x is equal to 2a, and from there whatever point means whichever point you choose and you draw the normal, you would be able to draw 3 normal from that point. Okay, hope this is clear. Now now let's come to the real problem here. Here it's approximately same thing, right? Last time we had discussed about this. This is a general equation of parabola, and general equation of parabola, just let me simplify this. X minus 1 plus y minus 1 square is equal to x plus y plus 2 root 2 square, right? This is the problem. Let me tell you what actually this problem is about. Excuse me. If hk is a point on axis of a parabola, okay, hk is a point on the axis of the parabola, and this is the parabola from where 3 distinct normal may be drawn, then prove that h is greater than 2. It means we need to draw true normal and then prove that h is greater than 2. Okay, h is a point on the axis of the parabola. All right, no problem. Okay, then we will find out the axis of the parabola first, and this is the general equation of the parabola. It means the distance from 1 1, right? Distance from 1 1 is equal to the distance from a fixed fixed line, right? Fixed line is x plus y plus 2. This is my fixed line. Let's assume this is fixed line. Okay, this fixed line, and we have a 1 1 over here, right? 1 1 over here somewhere, 1 1, right? And then yes, this is your parabola. Okay, this is axis of parabola. Okay, these are the axis of parabola. This is the point which is like s means 1 1. Okay, it is very clear from this. Distance between 1 1 is equal to, right, this is any point, distance between 1 1 is equal to this distance, right? Okay, now the same story here. You have from here to here it is anything, and then here you will have something. After that you have, if you have any point, right, if you draw a tangent from any point after that, it will fall where, means you would be able to draw 3 3 3 normal, not tangent. Okay, now let's apply some intelligence here. See, here s is 1 1. Okay, let me choose some different color. Yeah, s is 1 1. Can you tell me what is the distance between this s and this fixed line? Fixed line is x plus y is equal to 2. X plus y plus 2 is equal to 0. This is a fixed line, and this is a fixed point 1 1. If you draw if you find the normal distance from this to this, from s to this line, it would be 1 plus 1, right? 1 plus 1 plus 2 by root 2. 1 plus 1 plus 2 by root 2, right? It means 2 root 2. Okay, if I am correct, 2 root 2. Okay, 2 root 2 means this distance is root 2, and this distance again root 2. Okay, and what about this distance then? This distance should be root 2. Then what is this point? This point should be 2 2. Okay, if this is root 2, this and this point is 1 1. Okay, and this is m is equal to 1 for this. Okay, m is equal to 1 for this axis, because this is m is equal to -1 for this, m should be 1. Then if m is 1 means 45-degree inclination, and if this distance is √2 and is 0.11, this 0.11 and this point is again √2, it means, and these two distance are equal, it means this is 2 2. Okay, it means after 2 2 we got this line. Okay, after 2 2 means this, after this, if you choose any point, right, if you choose any point means this is what, this is line, right, and what would be the equation of line, and this line is exactly same but passing through this, the x plus y is equal to 4, right, this is the line, x plus y is equal to 4. I could say x minus y, x plus y minus 4 is equal to 0, right. If I will say x plus y minus 4 greater than 0, it means all points will fall under this, right, x plus y minus 4 is equal to 0. And what we say, then prove that all normal drawn from the point should be for them should be h is equal to 2. I would say, yeah, for that x plus y minus 4 should be greater than 0. Okay, and then just 1 sec. Okay, we got this equation. It means h plus k minus 4 should be greater than 0, simply. Okay, but one thing is given, like hk point should be there in the axis. Okay, and this is my axis, this is the axis, the h would be equal to k then, right, for this axis h is equal to k. Okay, if for this axis h is equal to k and all points are there in the axis only, means it says at what point of the axis, means normal are being drawn from the axis only, h will be equal to k, then you will have 2h minus 4 is greater than 0 actually. Okay, 2h minus 4, it means h should be greater than 2, right. This is what we wanted to prove, right, h should be greater than 2. Okay, this is what it is. Okay, fine. Okay, see you in the next lecture. Bye.